screen, right? Okay, so the major points that I would like to stress to those who are novice. This seems like a not very complicated model, but it's still complicated for you to make mistakes. So don't create first a model and then populate it with numbers and start running. Start with this one. Populate it with some numbers, make sure that you can run it, no mistakes, fine. Then add more, add some numbers, run it, no mistakes, add more. So this is a major process of modeling. The next step, how you populate the models, how you create parameters. So the major source is other models. So look at the models that have similar species, similar reactions, and use parameters from these models as the first goal. Then you can do some evaluation, fitting, and so on, but this is how to get them. And then I list several more databases. So again, you will have access to them. Pay attention to numbers when you look up at results. That if you have something steady at 300 and something that looks transient at e to the minus 9, it may be that your model is not really very informative, because such a different scales may be like not really correct from mechanistic point of view and from the simulation algorithms. So pay attention to units, especially when you base it on several different publications. So all numbers, they have units, and even if they don't have units, they have to be consistent. Again, pay attention to numbers. You may get, especially in spatial modeling, you may get absolutely amazing result that looks very beautiful, and then when you will pay attention between the difference between max and mean values in this diagram, you will see that they are almost the same up to the like tenth sign. So this probably is just artifact of simulation and not a beautiful pattern. Pay attention to parameters, that you don't mess up and don't use the same parameter in multiple simulations and then you override them. So in virtual cells, there is a way of like, and in Copasi also is when you can look just at parameters themselves. Pay attention to mathematics. Like after you do a model, you can look up at the actual mathematical model that gives you PD equations, initial conditions, diffusion, and so on. And if something goes wrong and you are mathematically savvy, you can look up at the math. Pay attention at algorithms. There are different solvers. There are different ways to use solvers, like you can do variable reduction and so on. So if your results are kind of weird, and especially if they're stiff, if like you have some of them on the order of hundreds and some of the orders of e to the 9, try different solvers, try different methods. Pre-equilibration. So when you do model, then you may tend to just start from numbers that are given in a database and papers. But sometimes before you add stimuli, you need to run simulations so all species have the same value, the steady state values. For spatial model, grid. So again, there is a trade-off between accuracy and speed of simulations. So you may have a very dense fine grid, but then your simulations will be stuck forever. Again, accuracy. There are simulation parameters, like you have an absolute relative tolerance and so on. So check it. So always, and check it from the very beginning, what I said, just run very simple model, next more complicated model, and at each step, check that everything is consistent. Model exchange. We use two different tools here, Copasi and Virtual Cell. They talk between each other. They talk through this SBML core standard. So if you export from Copasi model, you can import it into Virtual Cell and vice versa. And you can also run them with other tools not taught during this course. And then the rest you just will look at the slides. That there are resources, there are different formats, and if interested, you can look up. So I took exactly 5 minutes. So now the next lecture is by Pedro, who will be talking about building large models from blocks. So I will stop my screen.
I can give out a couple of minutes for questions if there are questions from the audience. Some of these tips are quite important, so I can give some time for people to ask.
Maybe I could add something to both the as a tip, but really applying to spatial modeling. I think it's always important to run a compartmental model, to run a non-spatial model first, and see how it behaves before you run the corresponding spatial model. Spatial models are more computationally expensive, but they're also more complicated to interpret. So it's always good to see that your system is behaving more or less as you would hope it would, or at least is in a way that you can explain by running an ODE model, or well, an ODE model is the best to explore how the system works, and then try to elaborate on that by adding space if necessary.
Yep.